Hello guys, welcome once more to another video in our YouTube channel. This is episode 2 of the 2023 paper 1 physics northwest regional mock questions. So episode 2 is going to contain the questions and the solutions from question 11 right up till question 20. For those of you that have not watched episode 1, endeavor to go to this channel and navigate through. You are going to see episode 1. Episode 1 contained questions from 1 to 10 with their extensive solutions. Before we begin, I would like us to have a word of prayer. So we are praying. Dear Heavenly Father, as we come together in this virtual space today, we thank you for the opportunity to learn and grow together. We ask for your guidance, we ask for your wisdom as these students prepare for their upcoming GCE examinations of 2025. We pray that you help each student to focus and absorb the knowledge that will be shared in this video today. We also pray that you make them feel motivated and confident in their abilities. We pray that you grant them clarity of mind to understand any complex solution that is going to be presented in this video of today. That we pray, oh Lord, that you help them to manage their time wisely and also to reduce the anxiety that they feel about the examination. We have prayed in Jesus' name. Amen. Okay, so for those of you who are just joining us for the first time, endeavor to like the video, share the video with your friends, and also subscribe to the channel. So without wasting much of your time, let us go straight away to what we have for you today. Okay, so we are going to begin with question 11, which is on photoelectric effects. The question reads, a metallic surface is irradiated by monochromatic light of frequency F1 and stopping potential is found to be V1. If light frequency F2 irradiates the surface, the stopping potential will be, we have a V1 plus H on E into F1 plus F2, B, V1 plus E on H into F2 minus F1, C, V1 plus E on H into F2 plus F1, and D, V1 plus H on E into F2 minus F1. Okay, so first things first, we are going to talk about the Einstein's photoelectric equation. Okay, so the equation is just an equation that is trying to relate the energy of a photon absorbed by an electron alongside its work function and its maximum kinetic energy. So the Einstein's photoelectric equation states that when an electromagnetic radiation of sufficient frequency is incident on a metal surface, the energy of a photon is absorbed by an electron to overcome its work function, and the rest is used as kinetic energy to emit the electron off the surface. So what we are saying is that the energy of a photon is HF is equal to the energy used to overcome the work function, which is HF0, alongside the kinetic energy, which is now used to emit the electron off the surface, which is specifically the maximum kinetic energy. Okay, so this is what we call the Einstein's photoelectric equation. Now, the maximum kinetic energy is half mv squared max, which is equivalent to EVS. Vs is what we call the stopping potential. Okay, and E here is the electronic charge of the electron. So we are just going to have HF to be equal to HF0 plus EVS. I'm doing this because in the equation I was told about stopping potential. So generally HF is equal to HF0 plus EVS. HF0 is a work function and F0 is what we call the threshold frequency of the threshold frequency of the light source. Okay, so I'm going to make Vs the subject of the formula. Okay, so the stopping potential, I will divide all through by E, then I'm going to subtract HF0 on E on both sides. So my stopping potential becomes H on E times F minus H on E times F0. So this is the equation we are going to use to get the relationship between the stopping potential of the stopping potential of the first light source its frequency and also the stopping potential of the second light source and its own frequency. Then we try to get the stopping potential of the second light source with respect to the frequency of the first light source as well as its stopping potential. Alright, so having the stopping potential generally to be h on E times F minus h on E times F0, we start with the first fact that, okay, if maybe we try to plot a graph of stopping potential Vs against frequency, it's going to give us a straight line whose slope is h on E and whose intercept is negative h on E times F0. If I plot y against x, my m is my gradient, which is h on E, and my c is my intercept, which is negative h on E times F0. So this is just a little demarcation of the graph. Okay, so the intercept is going to be negative. All right, h, e and F0 are all positive, so the intercept is going to be negative at the end of the day. So it's going to be cutting the stopping potential axis below and on the other side of the axis, okay, because it is negative. Now, how do I get F0? This F0 is the threshold frequency, and it is gotten when my stopping potential is equal to 0. Once my stopping potential is equal to 0, you realize that if Vs is equal to 0, your F will just be equal to F0, and frequency is positive. That is why it is intersecting the frequency axis at the point F0. Okay, so that was just to throw more light about that equation and maybe helping you in other questions of paper 1 or even data analysis of paper 2. So let's begin. If F is equal to F1, that is, if the frequency is equal to F1, we are talking about when we are taking the frequency to be the frequency of the first light source, okay, then its stopping potential Vs is equal to V1 according to the equation. So replacing everything back into this equation, we get that V1 is equal to h on E times F1 minus h on E times F0. F0 is the same because it is a specific metal. Okay, so the threshold frequency does not change because the work function of that metal is constant. So this is the first equation, and we are still going to use the fact that if F is now F2, that is, we are now using the frequency of the second light source, the stopping potential is now set to be V2, which is what we are actually finding. So doing that, we have that V2 is equal to h on E times F2 minus h on E times F0. So we are going to use equation 1 and equation 2 and see how to find V2 in terms of V1, in terms of h, in terms of E, in terms of F1, and in terms of F2. Alright, so having these two equations, it is clear that if we subtract the two equations, h on E times F0 is going to disappear because according to my options, I can't see any h on E F0. So I'm going to subtract the two equations so that I eliminate h on E times F0. And I'll start by taking equation 2 minus equation 1 so that my V2 is going to be positive. So equation 2 minus equation 1, I get V2 minus V1 equal to, now this guy cancels with this guy and I'll have h on E F2 minus h on E F1, but h on E is common, so we have h on E into F2 minus F1. So adding V1 on both sides of the equation, we get that the stopping potential of the second scenario is the stopping potential of the first scenario plus h on E into F2 minus F1. So this is the stopping potential in the second scenario, and if you check the options, you realize that option D is correct. Okay, so question number 12 is on capacitors. The question reads, some 20 identical capacitors, each of capacitance 3 microfarads, are connected in series. The combined capacitance of all the capacitors is, A says 60.0 microfarads, B says 0.15 microfarads, C says 6.67 microfarads, and D says 6.0 microfarads. So basically I just drew a little diagram indicating how the capacitors were connected in series. There are 20 of them. So we have C1, C2, C3, C4 right up till C20. So all these capacitors are in series. So to get a combined capacitance, we are going to treat these capacitors as resistors in parallel. Okay, so all these capacitors C1 right up to C20 are identical to each other, and they have the same capacitance, which that capacitance is 3 microfarads. So if CT is a total or the combined capacitance of these capacitors, then by definition 1 on C total is equal to 1 on C1 plus 1 on C2 plus 1 on C3 right up till plus 1 on C20. But we know that C1 right up to C20 are all the same, so we are basically adding 1 over C plus 1 over C plus 1 over C 20 times. Adding something to itself 20 times is like multiplying it by 20, and if I multiply 1 over C with 20, I get 20 on C. But 20 on C is 1 over C total. So to get C total, I'm going to take reciprocal on both sides, or I cross multiply. So C total is going to give me C on 20, but C is 3 microfarads, and if I take 3 microfarads divided by 20, I get exactly 0.15 microfarads. So the combined capacitance of all the capacitors is 0.15 microfarads, telling us that option D is correct. Okay, so we are moving to question 13, which is on electricity. A manufacturer of a battery specified that it has 36 ampere hour capacity. The term 36 ampere hour denotes the battery's A. Electrical energy content, B. Electric current, C. Electric charge, and D. Electrical power. So this is just basic definitions from theoretical part of physics. So electric current is the rate of flow of electric charge, and when we are talking about the rate of flow, we are talking about rate of flow with respect to time. So what we are saying is that the electric current is how much charge passes through a given point in a circuit per unit time. So electric current is Q on T. So by definition, the electric charge is the current times the time. Okay, now we need to know that electric current is measured in amperes or kiloamperes or milliamperes. In fact, the unit is amperes, and time is measured in seconds or minutes or hours, and so on and so forth, which means that 36 ampere hour is going to denote the battery's electric charge, because it is a product of current and time, ampere for current and hour for time, telling us that option C is correct. So the term 36 ampere hour with respect to the battery is the battery's electric charge. Okay, here we are with question 14. It's on optics, specifically lenses. In fact, it is a situation of combined lenses, so I will need you guys to pay keen attention to the solution. It reads, an object O is placed 15 centimeters in front of a converging lens of focal length 10 centimeters. A diverging lens of focal length 8 centimeters is placed 24 centimeters from the converging lens and to the right of it. The distance of the final image from the diverging lens is A. 30 centimeters, B. 24 centimeters, C. 20 centimeters, and D. 15 centimeters. So what is happening is that if this is my principal focus, okay, I first of all have a converging lens. Okay, this is the little representation of a converging lens. Okay, then I have an object O. Okay, now let me just say that this is my object. This object is placed at a distance of 15 centimeters from this converging lens, and they give us a focal length of this converging lens as 10 centimeters. Now we also have a diverging lens. Okay, we have a diverging lens, and this is how we represent a diverging lens. Okay, this is a little representation of the diverging lens. We have a diverging lens which is placed at a distance of 24 centimeters from the converging lens. Okay, and the question is asking us to find the distance of the final image from the diverging lens. So let's just try to draw a ray diagram. Okay, now imagine that this diverging lens was not there. So let's first of all imagine that the diverging lens was not there. If that lens was not there, if rays from the objects, okay, incident on the converging lens, at first instant they are perfectly horizontal, but this converging lens is going to converge them, okay, to fall on the principal axis. So this is where the image is going to be formed. So this converging lens actually converges those rays. So I have a ray of light horizontal. The ray through the principal focus is undeviated, is unconverged, okay, but the rays that are not going through the principal focus are being converged. So if this is my object O, okay, this is the image of the object. I can call it I1. That is in the case where the diverging lens is not there. But now come to think of it, if we now place a diverging lens, imagine I now place a diverging lens. This is now my diverging lens. Okay, if I place a diverging lens here, you realize that once these rays meet the diverging lens, they cannot just pass through, they are going to be diverged. Okay, so these rays are going to kind of move like this, okay, because the diverging lens diverges the rays, and to get the position we have to extrapolate backwards and we get where the final image is going to be formed. So this is where the final image is going to be formed in the case where the diverging lens is now placed. Our objective is to find the distance from this final image, okay, to the diverging lens. So the distance of the final image to the diverging lens, or the distance of the final image from the diverging lens. That is what we need to find. So I'm going to give you guys the steps we are going to follow to be able to get this distance. So first of all, to find this distance, to find the distance from the diverging lens of the final image form, we are going to first of all find the distance of the image I1 from the converging lens. So we are first of all going to consider that there was no diverging lens. So we are going to find the image of we are going to find the distance of the image I1 from the converging lens, okay, because this image I1 becomes the object of the diverging lens. So after finding that distance, we have said that definitely this image becomes the object of the diverging lens. I'm going to call that object O1. Then we are now going to find the distance from this image, which is from the converging lens. We are going to find its new distance from the diverging lens. Since it is the object of the diverging lens, its image distance becomes our final image distance. Okay, so we are now going to find the distance of the object, which is O1, and this object is definitely the image of the converging lens, which is I1. So we are going to find the distance from the diverging lens. Okay, and that is it. Okay, so I just drew a little diagram so I can use to explain. So first of all, we are going to find the distance from the object. We are going to find the distance of the image I1 from the converging lens. This I1 is the image of the converging lens. Okay, so then later we now need to find the image from the distance of this image here, okay, from the diverging lens, which is now the image I2. But remember that this image I1 becomes the object of the diverging lens. Sorry. Okay, so let us find the distance V1 of I1 from the converging lens. So I'm going to call that the image distance of I1 from the converging lens is V1. Okay, so we are going to use the lens formula, which is 1 on F equal to 1 on U plus 1 on V1, which means that 1 on V1 is 1 on F minus 1 on U. F is 10, is positive because it is for a converging lens, and U is 15, the distance of the object from the converging lens. So simplifying, you're going to get your V1 to be 30 centimeters, which means that the distance of I1 from the converging lens is 30 centimeters. Now, next thing we are going to do is we are now going to find the distance V2 of I2 from the diverging lens, still using the lens formula. So I'm now going to find the distance of the new image from the diverging lens. Okay, but now still using my lens formula, 1 over F will be equal to 1 over U1 plus 1 over v1. My u1 is the object distance from the diverging length, which is the distance from this I1 to the diverging length. I'm calling it u1, okay? And then my v2 is the image distance from the diverging length, which is the distance from I2 to the diverging length. My f is the focal length of the diverging length. Okay, now having that in mind, we need to find that distance v2. Okay, so we know that 1 over f is 1 on u1 plus 1 on v1, which means that plus 1 on v2, which means that 1 on v2 is 1 on f minus 1 on u1. So my v2 will give me f times u1 divided by u1 minus f. If you try to simplify by taking the LCM, then you later take the reciprocal. This is going to be v2. Now, what is u1 and what is f? Let us get u1. We said that u1 is the distance of I1 from the diverging length, okay, because this I1 is now the object of the diverging length. So u1 is the object distance from the diverging length. And we clearly see that if we take 24 plus u1, we must get v1, which was 30, because we found out that this image I1 is at a distance of 30 centimeters from the converging length, which means that if I take 24 plus the u1, I must get a 30 centimeters. So u1 is equal to 6 centimeters. But this u1 is behind the diverging length, so it has to be negative because it is behind the diverging length. Okay, now what about your f? Your f is also negative because it is a focal length of a diverging length. So we just have to replace f with negative 8 because according to the equation the focal length was 8, but because it is a diverging length it has to be negative. So negative 8 times, what is your u1? Your u1 is negative 6 because we are taking negative since it is behind the diverging length. Now your u1 is negative 6, then minus negative 8. Simplifying, you are going to get 24 centimeters. This tells us that option B is correct. You have the possibility of taking the video backwards and forward to be able to really get the idea behind this question. Okay, so in case you have not understood, you have the possibility of taking the video backwards and forward, okay, to perfectly understand. So option B is correct. Okay, so after this question we are going to be left with 5 questions. So this question is on magnetic fields, magnetism, and the question reads: Figure 3 shows two straight conductors X and Y placed 0.50 meters apart and carrying current 5.0 amperes and 2.0 amperes respectively in the same direction. At what point on a line that is perpendicular to the conductors will the resultant magnetic field be 0? So here is a diagram. We have current, we have two conductors carrying current in the same direction placed at a distance of 0.5 meters apart. The currents are like currents because they are in the same direction, and their magnitudes are 5.0 amperes and 2.0 amperes. 5.0 amperes for the conductor X and 2.0 amperes for the conductor Y. Okay, so I'm going to give you guys what magnetic field is actually. That is, what is the resultant magnetic field. So the resultant magnetic field between the two parallel, because the guys are parallel, okay, so the resultant magnetic field between the two parallel wires carrying current is 0 at a particular point where the magnetic field strength due to each wire are going to cancel each other. So imagine that I suppose that, okay, this is the point where the magnetic field strength, where the magnetic field strength are going to cancel each other. Let me just call this point P, okay? Now, first things first is that this point is going to be at a distance of Y from conductor Y, and it is going to be at a distance of X from conductor X, okay? So at this point, the resultant magnetic field due to the two conductors is equal to 0. So by definition, what is the definition of magnetic field at a point? So the magnetic field at a point P, which is at a distance R from any conductor which is carrying current, I is given by B equal to mu 0 I on 2 pi r. Mu 0 is a permeability of free space, I is a current of that particular conductor, and r is a distance from that point to the conductor. 2 pi is just a constant. So the magnetic field at a point P due to the conductor X is just mu 0 times the current in the conductor X divided by 2 pi times X, because X is the distance from the conductor X to the point P. Okay, so at a point P, we have said that the magnetic field due to conductor X is equal to the magnetic field due to conductor Y, because at this point the resultant magnetic field is equal to 0. Okay, now what is the magnetic field due to conductor X at a point P? It is mu 0 Ix on 2 pi X, because mu 0 is permeability of free space, your Ix is a current in conductor X, and your X is a distance between conductor X and a point P. Same thing happens for the magnetic field due to conductor Y, mu 0 Iy on 2 pi times Y. 2 pi cancels 2 pi, mu 0 cancels mu 0, we cross multiply, we get that Ix times Y is equal to Iy times X. Now we have to know that X plus Y must give us a distance between the two parallel conductors. So X plus Y must give us 0.5, which means that X will be equal to 0.5 minus Y, or Y is 0.5 minus X. So having this in mind, we need to find the distance X or Y. Okay, then we compare with the options. Okay, so okay, it is like I don't know if we have a little breakdown in that question. I don't know if we have a little breakdown in that question, but just for the little break, I will still try to inform you guys about preparatory classes for Concours examinations that begin immediately after the GCE on the 16th of June. In episode 1, I told you guys about Concours centers in the center region and the littoral region, where you have to use the MAFA registration code, and I forgot to tell you guys about the northwest region. So in the northwest region, MAFA works with the group called Superposition. Okay, so if you need more information about that group in the northwest region, you have to get to me and I'm going to direct you. So it shows that there is a little breakdown in that question. Okay, there is a little breakdown in that question. So I think in the next episode I'm going to complete that question 15. Okay, but the option was A. It just had a slide containing the final solution. A particular slide was repeated, which is an error from my side. So in episode 3, I'm going to start solving that question before I go into solving the questions of episode 3. So let's just proceed with question 16. Okay, all right, question 16 is on circular motion, and the question reads: a moving sport car overturned along a circular track of radius 100 meters. If the coefficient of friction between the road and the tire is 0.2, then the maximum velocity of the overturn of the car is, we have A 14.0 meters per second, B 20.0 meters per second, C 1.40 meters per second, and D 19.8 meters per second. Okay, so I'm just going to give a little diagram where kind of think about a car is trying to turn in a circular track. Okay, if the car is trying to turn like this, you realize that the force that causes it to move towards the center of the circular track is a centripetal force, which is being balanced by the frictional force. Okay, now at that particular instant, there is a normal reaction, and then there is also the weight. So the normal reaction is a normal reaction of the circular track on the car, and there is a weight which is being exerted by the car on the circular track, and all the forces in all the directions are in equilibrium. So on a circular track, the frictional force is provided by the centripetal force, which means that Fr is equal to Fc. But the frictional force is mu n, where n is a normal reaction and mu is a coefficient of friction, and the centripetal force is mv squared on r. M is the mass of the car, v is the velocity, and r is the radius of the circular track. So making v squared the subject of the formula, we just multiply by r and divide by the mass. V squared becomes mu n r on m. But we also know that the normal reaction and the weight are in Newton's third law pair, so the normal reaction is equal to the weight, so N is equal to mg. Replacing N with mg in this equation and getting V, you get V to be equal to the positive square root of mu gr. Mu is a coefficient of friction, g is the acceleration due to gravity, and r is the radius of the circular track. So doing the numerical applications, we get exactly 14.0 meters per second, telling us that option A is the correct option. Alright, question 17 is on the principle of superposition of waves. So the question reads, superposition can occur A, for any wave type, B, only for identical wave types, C, only for unidentical wave types, and D, if two transverse waves polarized at right angles were to meet. So the first assignment I'm going to give you guys to tell me in the comment section is, what is the principle of superposition of waves? So state the principle of superposition of waves in the comment section. Okay, so basically superposition is going to occur when two or more waves of the same type that is identical cross each other. Now when these waves cross each other, what happens is that there's a resultant wave that is formed, and this resultant wave has a displacement which is equal to the vector sum of the displacement of the individual waves, which means that clearly option B is correct. So superposition occurs only for identical waves. So like I said, you have an assignment which is telling me what the principle of superposition of waves says in the comment section. Alright, question 8 is on the principle of conservation of momentum. The question reads, an arrow of mass 120 grams is fired into a block of wood whose mass is 0.060 kilograms resting on a table. If the arrow and the wood fly off the table at 8.0 meters per second, what is the speed of the arrow? Is it 40.0 meters per second, or 4.0 meters per second, or 1.5 meters per second, or 4.8 meters per second? So I'm just going to give you guys the diagram that I drew. So we have a table, we have the wood of mass 0.06 kilograms, we have the arrow moving with an initial speed of UA. Now they move together after collision with a common velocity of 8.0 meters per second. So we are going to apply the principle of conservation of linear momentum along the line joining the centers of the two bodies. It says that the momentum before they collided is equal to the momentum after they collided. By definition, momentum is the product of the mass and the velocity. So which means that the initial momentum is the sum of the initial momentums of the first and the second body. So MA/UA for the arrow and MW/UW for the wood equal to MAVA, that is after collision, for the arrow plus MW/VW. Now, what is your UA? Your UA is actually what you are looking for. Okay, what is your UW? Your UW is 0 because it is the initial velocity of the wood, and the wood was resting. If you're resting, it means that if you are at rest, it means that your initial velocity is 0. So this part completely wipes off. What is VA and what is VW? Your VA and VW are all equal to each other, which I'm going to call V, because both of them collide and then they move up. They move off the edge of the table with a common velocity of 8.0 meters per second. So doing that, we have MA/UA equal to, since my VA is equal to VW equal to V, it means that replace VA with V, VW with V is common, factorize it, you'll be left with MA plus MW as a coefficient of the V. Now we need to get UA. So UA is MA plus MW times V divided by MA. Now we have to do the numerical application. Your MA is 120 grams, but we need to take it to kilograms. That is multiplying it by 10 to the negative 3. Your MW is 0.6. It's already in kilograms. Your MA, like we said, we need to take it to kilograms, and your V is 8. So simplifying, we are going to have exactly 4.8 meters per second as the initial speed of the arrow, telling us that option D is correct. Okay, the last but not the least question 19 on gravitational fields. The question reads, a planet follows a circular orbit of radius r round a star. The planet experiences constant centripetal acceleration A. How long does it take for a planet, that is for the planet, to orbit the star 4 times? So this is just a simple scenario of what is happening. We have a planet orbiting a particular star in a circular orbit. Okay, at different points, you see that the planet is going to be moving in a circular orbit. So we have the centripetal force, which is pulling the planet towards the center of the circular orbit. Okay, now we also have, since the star is massive and the planet is massive, we also have a gravitational force of attraction between the two of them, which is provided by the weight of the planet when we are talking about the planet alone. So first things first, we have that when a planet orbits the star, the centripetal force is provided by the gravitational force. Okay, that is when the planet is orbiting the star, we have that there is a force that is attracting two of them, is a gravitational force of attraction, because both objects have masses, and at the same time that gravitational force of attraction is pointing towards the planet. Okay, because the planet is more massive than the star. In fact, in this case we can say it is pointing towards the star because the planet is what is orbiting the star. And again, since it is pointing towards the star, at the same time you realize that it has to be equal to the centripetal force. Okay, it depends on which one is massive. I think the planet has to be massive, so we are going to have a gravitational force pointing towards the planet, but the centripetal force is pointing towards the star, so they are going to balance each other. So the centripetal force is equal to the gravitational force, but the centripetal force is m omega squared r, where the m is that of the planet, okay, because the planet that is orbiting, and then the gravitational force of attraction is g mpms on r squared, where r is the distance separating both of them, which is basically the radius of the path. Your mp is the mass of the planet, ms is the mass of the star, and g is the universal gravitational constant. So from here your mp is going to cancel, and we see that the omega squared is equal to gms on divide both sides by r is actually r squared times r, which is r cubed, but we have a reason of writing r squared and r. Remember that we need to find how long it takes the planet to orbit the star, so we have to kind of find the period, then we now relate the time taken with the period, okay? Because the time taken to orbit the star once is the period, but we need the time taken to orbit the star 4 times. So for me to get period, I must try to be getting the angular velocity, which is omega. Okay, now when it concerns the planet alone, the gravitational force of attraction is provided by the weight. Okay, so gravitational force of attraction equal to the weight. We have that mpg, that's the weight of the planet, is mp times g, equal to the gravitational force of attraction between the planet and the star, which means that our gravitational field strength, which is g, is equal to gms on r squared, because mp is also going to cancel. Okay, now you see that from here, gms on r squared is just small g, but now there is an r in the denominator, so replacing gms on r squared with small g, we are going to have omega squared to be small g on r. Okay, so having omega squared to be g on r, it means that g is omega squared r. But again, by definition, what is the centripetal acceleration? It is omega squared r. So your centripetal acceleration and your gravitational field strength are all equal to each other. So AC, which is my acceleration, centripetal acceleration, is equal to g. Now from there, I think we can get period. Period is 2 pi on omega. Okay, so omega is basically the square root of g on r. So we have 2 pi divided by the square root of g on r. Okay, so taking this guy to the numerator, we get 2 pi the square root of r on g. Okay, but now we know that this g is equal to the centripetal acceleration. So my period, which is the time taken for a single orbit, is 2 pi the square root of r on a. Okay, but we need the time taken for you to orbit the star 4 times, so we have to multiply your period by 4, since your period is the time taken for you to orbit the star once. So multiplying by 4, 2 pi times 4 gives us 8 pi, then we multiply the rest with the square root of r on the centripetal acceleration. So if you look at the options, option B is a perfect choice in this question. So let's move to the last question, which is question 20. Okay, so question 20 reads, it's on current electricity. Why does running too many appliances on one circuit cause the fuse to blow or circuit breaker to shut off? These are the different options. So I'll basically just present to you guys the explanation, and then I think we are going to now get the option. So read what is going to be displayed to you on your screen. Okay, so if you're done reading, you will just realize that the correct option is option C. As more and more resistors are added in parallel, the total resistance decreases, and when resistance is decreasing, current is going to be increasing from Ohm's law of V equal to IR. So if V equal to IR, I is equal to V on R. So with the same voltage drop, with a constant voltage drop, increasing the resistance, increasing the resistors in parallel decreases the total resistance, hence increasing the current, since there is an inverse proportionality or inverse or indirect relationship between current and resistance. So question 20 is C. Okay guys, we have come to the end of episode 2, which we are solving question 11 to question 20. But remember that we had a little break in question 15, which we are going to solve that question 15 again in episode 3. Okay, but I said the answer was A. So I think if you just continue from where we ended using the informations given, you're going to have option A as a correct option. But for benefit of doubt, in episode 3, which is going to be solving question 21 to question 30, we are going to include again question 15. All right, so for those of you who have not watched episode 1 and the other episodes that are going to be upcoming, make sure you watch those episodes. Okay, don't forget to subscribe to the channel, comment in the comment section, like the video, and share with your friends. Together we are going to make physics paper 1 an easier task for you at the GCE this year. Stay blessed and see you guys in episode 3.